There are two main classes of audio recording. Those are analog recording and digital recording. Recording quality depends on some major areas. Recording quality of the audio hardware. Sample rate of the recording. Record format. Audio hardware quality can measure by some key points such as audio input and output latency, sample rate used, audio buffer size, etc. If the input and output latency are low, then the audio device is functioning more precisely for the recording purpose without having delays. Sample rate or the sample frequency defines the number of samples per second taken from a continuous signal to make a discrete signal. The concept of sample frequency can only be applied to samplers in which samples are taken periodically. Some samplers may sample at a non-periodic rate. For digital recording, digital playback, this accuracy depends on the range of sound which is sampled, the rate at which it is sampled, and the various conversions that occur in any sound reproduction system. Normally there are few record formats. Default record format is 24-bit. As well as there are 8, 16, and 32-bit record formats used for various requirements in various types of softwares. In the music industry, they are using many recording softwares as well as the hardware devices. To implement that softwares, many programming languages are used. Let's look at the sample Java program, which we are using to demonstrate the key functionalities of audio engineering.
In this module, we can see some buttons in the left-hand side. In the topmost corner there are linear, mu-law, and A-law buttons. Those methods are used when digitizing speech as noise reduction techniques, and to derive the range of the human hearing sensitivity. Mu-law is used only in United States and Japan, and A-law is used in all other countries. Then there are buttons which has values as 8,000, 16,000, 44,100, etc. Those are the basic sample rates that are taken to configure the recording quality. Normally we are using 44,100 Hz as the default sample rate. We can select either the track that we are recording as a stereo or mono track.
Java Sound API provides a vast variety of manipulation of digital audios and MIDI synthesis. It has main two packages which supports this features. One package is Java Sound Sampled and other one is Java Sound MIDI. Java Sound Sampled. This package specifies interfaces for capture, mixing, and playback of digital audio. Java Sound MIDI. This package provides interfaces for MIDI synthesis, sequencing, and event transport. Capture playback is a Java file which manipulate audios in different formats and then play the recorded audio. The captured wave can be saved either as a WAV, AU, or AIFF, or load an audio file for streaming playback. Capture playback file has imported the sampled package. There are two classes in the capture playback file which called capture and playback. Both the classes have implemented the runnable interface, which means both are work on two different threads. The reason for the approach for the threads is, in both the actions accesses the one shareable file, for write and read. This class basically does reads data from the input channel and writes to the output stream. Get the format to be save the captured file from the user input. Create a data line which to be stored with the format of file. Get and open the target data line for capture. Define output stream. This set of codes convert the input frames into bytes and store in the byte array. Start of reading. This while loop read and write to the output stream until thread is being end of run method. We reached the end of the stream. Stop and close the line. Stop and close the output stream. This class basically does is write data to the output channel from the file definition of the playback class. Reset to the beginning of the stream. Get an audio input stream of the desired format for playback. Define the required attributes for our line and make sure a compatible line is supported. Get and open the source data line for playback. Playback the captured audio data. We reached the end of the stream. Let the data play out, then stop and close the line. End class playback. MIDI, short for Musical Instrument Digital Interface, is a music industry standard communications protocol that lets MIDI instruments and sequencers talk to each other to play and record music. The physical MIDI interface uses DAN connectors. MIDI is based on a ring network topology, with a transceiver inside each device. Most of the MIDI-compatible instruments have a built-in MIDI interface. Also, MIDI functionalities can be acquired via game ports, USB ports, FireWire, as well as through Ethernet. MIDI controllers are available in range of other forms, such as electronic drum triggers, EWI wind controllers, MIDI guitar synthesizers, MIDI keyboards, etc. General MIDI synthesizers are required to be able to allow 24 voices, including 16 melodic and 8 percussive voices, to be active simultaneously. MIDI events are triggered according to the note velocity. Also supports 16 channels, and polyphonic, which supports multiple simultaneous notes to occur. In MIDI, the instrument sound or program for each of the 16 possible MIDI channels is selected with a program change message, which has a program number parameter. This diagram shows the general MIDI standards using with percussion. General MIDI. Default MIDI synthesizer, which is available in most operating systems, consists with separate sets of instruments, such as pianos, percussions, set of guitar tones, brass, reeds, and pipes and sound effects, etc. Let's look at our sample program to get an idea about MIDI synthesizers in detail.